When I started my research back in 1967 at the University of Virginia, I was working with the early leaders of stem cell research. Biologists thought that genes would turn themselves on and off. However, in the stem cell cultures with which I was working, I noticed that the cells altered their gene expression based on their environment. My colleagues thought I was nuts. But in 1991, science finally realized that my observations were accurate, and they coined the new insights as the science of epigenetics. Scientific materialism, the civilization we're in right now, was actually founded in the works of Isaac Newton. He was studying the movements of the universe and looking at the universe as a machine. And why that was important is that Isaac Newton created what we call classical physics or Newtonian physics. And what's it based on? Well, Isaac Newton, in studying the movements of the planets of the solar system, interestingly enough, had to actually create something before physics. He created calculus. No little small adventure on the way to understanding physics. Using the calculus equations, what Newton did was put in the physical characteristics of the planets, how big they are, their mass, how fast they're moving, and the vectors of their orbits. And using this data, he solved the equations, and he was able to accurately predict the movements of the planets in the solar system. And you may say, well, what's the significance? And the answer to that is very important, because at the time of Isaac Newton, we were living in a civilization called monotheism. Well, this led to a belief in materialism. Isaac Newton, in providing this new insight, actually was considered a heretic because the church was running civilization and Isaac Newton's data did not fit the infallible knowledge offered by the church. However, to proceed, science had to make a détente with the church. And this is how it worked out, very simply this. Science said, we will only study the material, physical realm of the universe, leaving behind all the invisible stuff, and that they left to religion, such as spirit. This was a separation of physics and metaphysics. Physics saying, we will not deal with the invisible realm at all, we'll understand life just through the physical realm, and therefore not step on the feet of the church, which was actually running civilization. Now, to understand evolution, we must first go back to 1809. That was the printing of the first scientific paper on evolution by Jean-Baptiste de Lamarck. Lamarck's theory of evolution, in today's light of science, is probably the most accurate one. Lamarck recognized a very simple fact, that animals and environments were in a perfect lockstep orientation. Polar bears are not in South America, and orchids are not in Antarctica. Was that chance or accident? Not according to Lamarck. Lamarck actually came up with the idea that there was a lockstep interaction between the environment and the evolution of the organisms. Well, this theory got lost for a very important reason, and that is because Lamarck was only able to offer this new science in the French Revolution when Napoleon took over. But when Napoleon lost and the aristocrats and the church came back into power, they eliminated Lamarck immediately as a heretic, and that was the end. However, in 1859, a theory of evolution by Charles Darwin was published on the origin of species by natural selection. I want to make a very important correction at this moment for this fact because we give credit to Darwin for the theory. The truth is, it was Alfred Russel Wallace, a commoner working in the Malay archipelago, that actually wrote the theory of evolution and sent it to Charles Darwin. Darwin was taken back by the fact that someone had already written this theory and he didn't finish his effort of writing his theory. Well, Charles Lyell, head of the Royal Society, and Darwin got together, and under what they referred to as the delicate arrangement, they put Darwin's name in front of Alfred Russel Wallace's name when presenting the theories at the Linnaean Society meeting back in 1858. The significance is profound because priority is always given to the first author. Darwin took the work and within the year came out with his book on the origin of species. And Wallace lost in history. Now, the significance of Darwin writing the theory is quite different than understanding Alfred Russel Wallace's perception. Wallace, a commoner, when he saw the understanding of how animals in the world work together and compete with each other, actually came to the conclusion that evolution was based on the elimination of the weakest organisms in the community. Darwin, an upper-class person, and in supporting the upper-class philosophy, changed that around and said that evolution is actually driven by the survival of the fittest in the competition. So Wallace said it was elimination of the weakest. Darwin said it was the preservation of the strongest. They both have the same conclusion, the glass is half empty or the glass is half full, but they have profoundly different meanings. Because if I give you a chance to live in either of two worlds, an Alfred Russel Wallace world where only the weakest get eliminated, or a Darwinian world where only the strongest survive, which one would you pick? Think about it. The answer is simple. It's easiest to be an Alfred Russel Wallace because it's easiest not to be the weakest. It's much harder to be the strongest, as in a Darwin world. But Darwin was the first one to write his book on the origin of species. And since then, the world has been taken by the understanding that it is a competition for survival on this planet. And therefore, in trying to understand the nature of evolution, we must first go back to Isaac Newton. And the significance is this. In Isaac Newton's universe, the physical material realm can only be affected by other forms of matter. And therefore, in trying to understand how a human body works, and human body being a physical machine, it was understood that somewhere in that body there were physical elements that controlled the character of that machine. And when Darwin came up with this idea, there was no insight or understanding of the nature of genes. It was a philosophy that there were some kinds of structures like paint droplets scattered through the body, and that these droplets were called gemmules. And these gemmules carried the nature or character of the part of the body where they were located. So there'd be a gemmule in your shoulder that would accommodate the shoulder, a gemmule in your neck that would program and develop the neck. So gemmules were scattered all over the body. When two people mated, the gemmules of the mother and the gemmules of the father would come and blend together to create the characteristic of their offspring. In searching for those physical elements, the gemmules, we were looking for the Genesis elements. And Genesis elements can be abbreviated as genes, and that's where the term genes comes from, okay? So the significance is this. Darwin's theory was a two-step process. Step one, there's an alteration in the heredity that the so-called gemmules would alter their characteristic, which in turn would alter the characteristic of the body in which these gemmules were found. Followed by step two, natural selection, where nature will select the strongest of those altered organisms to survive and propagate those genes and eliminate the weaker organisms that have been altered by these genes. Nobody had any idea about DNA and its mechanism. In 1953, the answer of how DNA works was provided in the journal Nature by Watson and Crick. And Watson and Crick have been given all the credit for understanding that DNA is a double helix and encodes a gene program to provide for the characteristics of an organism. I just want to make a point right here, it's very important, that Watson and Crick were actually not the real founders of the DNA double helix. It was a woman, Rosalind Franklin, who through her research on DNA molecules first showed the picture of an X-ray characteristic of a DNA double helix. Interestingly, Rosalind Franklin's major advisor gave her research results to Watson and Crick without even telling Rosalind Franklin that he did it. It was that research that led to Watson and Crick coming forth with the famous DNA double helix picture in 1953. Well, once we started to understand the nature of DNA, we start to recognize that it is what is programming the character of an individual. It is responsible for heredity. And now comes a serious issue, because the chromosomes carrying these genes which control our character, well, we get them from our mother and our father at the moment of conception. Every gene blueprint can give rise to over 3,000 different versions of proteins from the very same gene blueprint because of epigenetics.